Assalamu alaikum dear students, welcome to my YouTube channel Chemistry to the Point. Dear students, we have changed our channel name from the learning process by chemistry to the point. We are present here with lecture number 5, which is the relationship between Gram and a.m.u. Dear students, in this lecture we will derive that 1 gram is equal to 6.023 multiplied by 10 raised to the power of 23 a.m.u. This relation will be derived with the help of 3 examples. In the first example, we have taken carbon atom. In the second example, we have taken oxygen atom. While in the third example, we have taken water molecule. But dear students, if you have not watched lecture number 4, A, B and C, you are advised to first watch lecture number 4, then it will be very easy for you to understand, to derive, to understand the derivation of this relationship. So dear students, let us to start with the example of carbon atom. We know, dear student, that the atomic mass of carbon, is equal to 12 a.m.u. It means that single atom, that mass of single atom, mass of single carbon atom is equal to 12 a.m.u. It means that the mass of a single atom of carbon is equal to 12 a.m.u. Now dear students, here a question arises that what is the mass of a single atom of carbon in gram? Listen again, what is the mass of carbon atom? What is the mass of a single atom of carbon atom in grams? So we will derive the mass of a single atom of carbon atom from the relationship of mole and Avogadro number. How? Let us to understand. Dear students, we know that the mass of Avogadro number of carbon atoms is equal to 12 gram, which is called molar mass. So dear students, here we will write number of carbon atoms ratio mass in grams. Number of carbon atoms 6.023 multiplied by 10 raised to the power of 23 is equal to 12 gram. It means that the mass of Avogadro number of carbon atoms is equal to 12 gram. Then what will be the mass of a single atom of carbon in grams? One atom of carbon, mass of one atom of carbon is equal to x gram. Dear students, what is x? If we calculate x, we will calculate the mass of single atom of carbon in grams. Listen again, dear students. What is x? If we calculate x, x is the mass of a single atom of carbon in grams. So let us to calculate the mass of a single atom of carbon, which is represented by x. So we will cross multiply these. We will get 6.023 multiplied by 10 raised to the power of 23 is equal to multiplied by x is equal to 12 gram multiplied by 1. We have cross multiplied. Then we want to calculate x. X will become equal to 12 gram multiplied by 1 divided by 6.0 19.23 multiplied by 10 raised to the power of 23. So, by dividing 12 on 6.023 multiplied by 10 raised to the power of 23, we will get, dear students, 1.9924. 1.9924 multiplied by 10 raised to the power of minus 23 gram. 12 divided by 6.023 is equal to 1.9924 multiplied by 10 raised to the power of minus 23. This is 10 raised to the power of 23 at 12 raised and will become equal to minus 23. So, dear students, x is equal to 1.9924 multiplied by 10 raised to the power of minus 23 gram. So, dear students, as we have already told that what is x? X is the mass of a single atom of carbon in grams, which is equal to 1.9924 multiplied by 10 raised to the power of minus 23 gram. Here you see, dear students, this relationship. Dear students, you may see this relationship. The mass of a single atom of carbon in a.m.u is equal to 12 a.m.u, and the mass of a single atom of carbon is equal to 1.9924 multiplied by 10 raised to the power of minus 23 gram. It is also one carbon atom. It is the mass of one carbon atom in grams. It is the mass of one carbon atoms in a.m.u. What does it mean? It means that 12 a.m.u is equal to these grams. It means that 12 a.m.u is equal to 1.9924 multiplied by 10 raised to the power of minus 23 gram. Dear students, for your understanding, let us to explain this relationship. For example, I have 1 kilogram tomato. These are, dear students, 1 kilogram tomato. If these tomatoes are measured by gram, if these tomatoes are measured with gram, then it will be equal to 1000 gram. Then what does it mean? It means that 1 kilogram is equal to 1000 gram. Similar is the case with a.m.u and gram. That 1.9924 multiplied by 10 raised to the power of minus 23 gram is equal to 12 a.m.u. Now, dear students, from here we will derive the relationship between gram and a.m.u. How? Let us to understand. So, dear students, from this relationship we know that 1.9924 multiplied by 10 raised to the power of minus 23 gram is equal to 12 a.m.u. Then 1 gram will become equal to x a.m.u. will become equal to x. What is x here? Dear students, x represent the number of a.m.u's in 1 gram. If we calculate x, we will calculate the number of grams. If we calculate x, we will calculate the number of a.m.u's present in 1 gram. So, let us to calculate. It will be cross multiplied. So, we will get x multiplied by 1.9924 multiplied by 10 raised to the power of minus 23 gram is equal to 1 gram we are writing everything with unit. 1 gram multiplied by 12 a.m.u. So we want to calculate x, therefore x will become equal to 1 gram multiplied by 12 a.m.u divided by 1.9924 multiplied by 10 raised to the power of minus 23 gram. So dear students, gram will be cancelled with the gram, and 12 divided by this, it will give x is equal to 6.023 multiplied by 10 raised to the power of 23, and the unit will be a.m.u. So dear students, we have calculated x, and x has taken this value. And what is x? X is the number of a.m.u's in 1 gram. Therefore, we can say that 1 gram is equal to 6.023 multiplied by 10 raised to the power of 23 a.m.u. So dear students, we have derived this relationship from carbon atom. So dear students, we have derived this relationship with the example of carbon atom. Now dear students, we will derive this expression with the example of oxygen atom. Example number 2. Oxygen atom. Oxygen atom. Such as we will derive this expression from oxygen atom. So dear students, we know that the atomic mass of oxygen atom, atomic mass of oxygen atom is equal to 16 a.m.u. It means, what does it mean? It means that mass of single oxygen atom, mass of single oxygen atom is equal to 16 a.m.u. It means that the mass of a single atom of oxygen in a.m.u is equal to 16 a.m.u. Now dear students, here again we will ask that what is the mass of a single oxygen atom in grams. For this determination, we will, dear students, we will take the help of mole and Avogadro number for this determination that what is the mass of a single atom of oxygen in grams. So let us to understand. So number of oxygen atoms ratio mass in grams. Dear students, from Avogadro law, dear students, from mole and Avogadro number, we know that 6.023 multiplied by 10 raised to the power of 23 oxygen atoms have a mass equal to 16 gram, which is called the molar mass of oxygen. It means that 6.023 multiplied by 10 raised to the power of 23 oxygen atoms have a mass in gram equal to 16 gram. Then what will be the mass of a single oxygen atom? If the number of oxygen atom is equal to 1, then the mass of this oxygen atom in gram will be equal to x. What is x? X represent the mass of a single oxygen atoms in gram. If we calculate x, we will calculate the mass of a single oxygen atoms in gram. So let us to calculate. So by cross multiplying, we will get x multiplied by 6.023 multiplied by 10 raised to the power of 23 is equal to 16 gram multiplied by 1. Now we want to calculate x, so x will become equal to 16 gram multiplied by 1 divided by this one, 6.023 multiplied by 10 raised to the power of 23. So dear students, by dividing 16 gram with 6.023, we will get 2.6565. We will get 2.6565 multiplied by 10 raised to the power of minus 23, and the unit will be gram, as you see here. This is the number of carbon atoms. In the denominator there is no unit. In the numerator, this one is also the number of oxygen atom. 6.023 multiplied by 10 raised to the power of 23, it is the number of oxygen atoms. In the denominator there is no unit. 1 is also the number of oxygen atoms. It have also no unit. This is 16 gram, which has the unit gram. Therefore x will take the unit gram. So what is this x? This is the mass of a single oxygen atom in grams. X is equal to 2.6565 multiplied by 10 raised to the power of minus 23 gram, and this is this mass of single oxygen atom. Single oxygen atom is equal to 2.6565 multiplied by 10 raised to the power of minus 23 gram. It means that the mass of a single oxygen atom in gram is equal to this one, and the mass of a single oxygen atom in a.m.u is this one. So what does it means? Dear students, if you look to this relationship, the mass of single oxygen atom in a.m.u is equal to 16 a.m.u, and the mass of single oxygen atom in grams is equal to 2.6565 multiplied by 10 raised to the power of minus 23 gram. So dear student, what does it means? It means that this amount of gram is equal to 16 a.m.u. Here again we will give the example of 1 kilogram of tomato. For example, dear students, it is 1 kilogram tomato. If someone measures this 1 kilogram tomato with some other unit of mass, for example gram, then it will become equal to 1000 gram. The quantity of matter is the same, but here the unit changes. That quantity of matter here is equal to 1 kilogram, and that quantity of matter here is equal to 1000 gram. What does it means? It means that 1 kilogram is equal to 100 gram. Similar is the case with a.m.u and gram. Here it means that 2.6565 multiplied by 10 raised to the power of minus 23 gram is equal to 16 a.m.u. This is a relationship which we have derived from the example of oxygen atom. Now let us to calculate again that how many a.m.u's will be present in 1 gram. We will calculate this relationship from this relationship. So dear students, as you look here, from this relationship we know that 2.6565 multiplied by 10 raised to the power of minus 23 gram is equal to 16 a.m.u. Then 1 gram will be equal to x a.m.u. So dear students, what does x represent here? X represent here the number of a.m.u's in 1 gram. If we calculate x, we will calculate the number of a.m.u's in 1 gram. So let us to calculate. It will be cross multiplied. So dear students, we will get x multiplied by 2.6565 multiplied by 10 raised to the power of minus 23 gram is equal to 1 gram multiplied by 16 a.m.u. So we want to calculate x. X will become equal to 1 gram multiplied by 6 a.m.u divided by this number. Dear students, gram will be cancelled with gram, and thus we will get 16 divided by 2.6565 is equal to 6.023 multiplied by 10 raised to the power of 23. It is minus 23, it will rise up and will become equal to 23, and the unit will be a.m.u. So what does it mean, dear students? What was x? X was the number of a.m.u's in 1 gram. So it means again that 1 gram is equal to 6.023 multiplied by 10 raised to the power of 23 a.m.u. So dear students, we have derived this expression again with the example of oxygen atom. Now dear students, we will calculate again the relationship between gram and a.m.u with the example of water molecule, so that you may understand that how this relationship is derived. It can also be derived from sodium atom, it can also be derived from magnesium atom, it can also be derived from calcium atom. It can be derived from every atom and from every molecule and from every compound. You can derive this expression. So example number. So dear students, example number 3. To derive this relationship from water. So dear students, from example number 3, in example number 3 we will take water, H2O. Let us to derive again this expression, this relationship from water molecule. So dear students, we know that molecular mass of water, molecular mass of water is equal to 18 a.m.u. But dear students, you are suggested that if you have not watched lecture number 4, A, B and C, you may watch first that lecture, then it will be very easy for you to understand this lecture. What does it means? It means that the mass of single water molecule, it means that mass of single H2O molecule is equal to 18 a.m.u. So dear students, here a question, we will raise again that question, that what is the mass of a single molecule of water in gram? We will derive this from the relationship between mole and Avogadro number. So dear students, number of molecules of water, number of molecules of H2O ratio, mass in gram, mass in grams. Avogadro number of water molecules such as 6.023 multiplied by 10 raised to the power of 23 water molecules have a mass equal to 18 gram. So the mass of a single water molecule, so the mass of one water molecule will be equal to x gram. We will cross multiply. So dear student, what is x? X is the mass of one molecule of water in grams. If we calculate x, we will calculate the mass of one molecule of water in grams. So let us to calculate. X multiplied by 6.023 multiplied by 10 raised to the power of 23 is equal to 18 gram multiplied by 1. We want to calculate x. X is equal to 18 gram multiplied by 1 divided by 6.023 multiplied by 10 raised to the power of 23. Thus we will get 18 divided by 6.023 is equal to 2.9885 is equal to 2.9885 multiplied by 10 raised to the power of minus 23. It will rise up and the unit will remain gram. Therefore, it means that the mass of one molecule of water in gram is equal to this one. So it means that the mass of a single water molecule, mass of a single H2O molecule is equal to 2.9885 multiplied by 10 raised to the power of minus 23 gram. So what does mean, dear students? It means that 18 a.m.u is equal to 2.9885 multiplied by 10 raised to the power of minus 23 gram, because a single molecule of water have a mass equal to 18 a.m.u and a single molecule of water have a mass equal to such number of grams. So dear student, it means that 2.9885 multiplied by 10 raised to the power of minus 23 gram is equal to 18 a.m.u. From here we will again derive the relationship between gram and a.m.u. From that relationship we know that 2.9885 multiplied by 10 raised to the power of minus 23 gram is equal to 18 a.m.u. So 1 gram will become equal to x a.m.u. So dear student, what is x? Here if we calculate x, x will be the number of a.m.u's in 1 gram. So let us to calculate. It will be cross multiplied. X multiplied by 2.9885 multiplied by 10 raised to the power of minus 23 gram is equal to 18 a.m.u multiplied by 1 gram. So X will be equal to 18 a.m.u multiplied by 1 gram divided by 2.9885 multiplied by 10 raised to the power of minus 23 gram. So gram will be cancelled with gram, and 18 divided by 2.9885 is equal to 6.023 multiplied by 10 raised to the power of 23 a.m.u. So dear student, X, what is X? X is the number of a.m.u's in 1 gram. So again 1 gram is equal to 6.023 multiplied by 10 raised to the power of 23 a.m.u. So dear students, we have derived this relationship by giving 3 examples. Example number 1, which was related with carbon, example number 2, oxygen atom, example number 3, water molecule. But dear student, this relationship can be derived from any atom and from any molecule. We can derive this relationship. Now dear students, conversion of gram and a.m.u to each other. How we will convert gram into a.m.u and a.m.u into gram? So dear student, gram is the larger unit, very larger unit, and a.m.u is the very smaller unit, and this is the conversion factor between gram and a.m.u. The conversion factor means that when we convert gram into a.m.u, it will be multiplied by this conversion factor, and when we convert a.m.u into gram, then we will divide by this conversion factor. As you see, dear students, here 2 gram will be equal to 2 multiplied by this conversion factor. Similarly, 3 gram will be equal to 3 multiplied by this conversion factor. 4 gram is equal to 4 multiplied by this conversion factor. So dear students, when we convert 1 a.m.u into grams, so it will be divided by the conversion factor. This is 1 and it has been divided by the conversion factor. When 1 is divided by this, we will get 0.166 multiplied by 10 raised to the power of minus 23 gram. So 1 a.m.u is equal to, we want to express it in scientific notation, then it will be multiplied by 10 as well as it will be divided by 10. So when it is multiplied by 10, we will get 1.66 multiplied by 10 raised to the power of minus 23 divided by 10. It has been multiplied by 10 and also divided by 10. And the first step, we have multiplied by 10, so we have get this one. Now divide by 10, we will get 1.66 multiplied by 10 raised to the power of minus 23, and it rise up 10 raised to the power of minus 1. Thus we will get 1 a.m.u is equal to 1.66 multiplied by 10 raised to the power of minus 24 gram. Now when this gram is converted into kilogram, it will be divided by the conversion factor, because the conversion factor between gram and kilogram, we know that 1 kg is equal to 1000 gram. So this is the conversion factor between gram and kilogram, such as when we convert kilogram into gram, then kilogram will be multiplied by the conversion factor, and when we convert gram into kilogram, then gram will be divided by the conversion factor, such as by 1000. So therefore here we convert kilogram, so here we convert gram into kilogram, such as the smaller unit into the larger unit. Therefore it will be divided by the conversion factor, which is this one, such as 10 raised to the power of 3. So we will get 1.66 multiplied by 10 raised to the power of minus 27 kilogram. It means that 1 a.m.u is equal to 1.66 multiplied by 10 raised to the power of minus 26 kilogram, and 1 a.m.u is equal to 1.66 multiplied by 10 raised to the power of minus 24 gram. It means that a.m.u is a very smaller unit. So dear students, this is the end of our lecture number 5. Thank you for watching our lecture and having a company with us.